The last lesson of chapter 2 is more on inequalities. If you take a look at this first example, what's different about this is we have a quadratic inequality versus other problems were linear inequalities. So your first step would be to get everything onto one side. Okay, now I like to think about these problems graphically, but you can proceed algebraically. So the next step would be to find the zeros, the x-intercepts. I'm going to do this by factoring. And let's see if we put a +1 here and a -3 there. That factors correctly, which means we have two important points. X equals 3 over 2 and x equals -1. Okay, these are the zeros or the x-intercepts for the quadratic equation. Now, since this is an inequality, I like to think about it graphically. So I like to draw a little picture, and this would be a U-shaped parabola curve. If we were to graph it, it would open upward and it would cross at -1, someplace about right here, and +3 over 2, someplace over here. And the graph would look something kind of like this. Okay, I'm just drawing a quick sketch because now I look at the problem and now I got to pay attention to the inequality that we have. This is a less than symbol, so what they're asking for is tell me all the x values that are less than or equal to 0. Basically, those are all the x values that are below the x-axis. So we're going to answer this with an interval, and you can see now the importance of knowing the x-intercepts being -1 and 3 over 2. So our answer would be from -1 to 3 over 2. We'd have to have parentheses on both of these. This is an interval. This means greater than -1 and less than 3 over 2. Next example. Oh, shoot. Okay, next example is very similar. I need to get everything onto one side and try to find the zeros or the x-intercepts. On this problem, I'm going to move everything to the right so that my leading coefficient would be a +3x squared. Now, again, I want to find the zeros, the x-intercepts. I'm recognizing and noticing that I can take a 3 out of every term, making the factoring much easier. Okay, so in doing this, we find out we have two important points, x equals +2 and x equals +5. Okay, these are the zeros or the x-intercepts. So again, I like to draw a graph, draw a picture. I like to think about it graphically. Okay, and if we pay attention to this problem right here, this equation, or this inequality, excuse me, this is going to be a U-shaped parabola curve that opens up. And it's going to cross at +2 someplace over here, and then also at +5 someplace over here. That's going to open upward. So it's going to look like this. And now I have to pay attention to the inequality symbol. Now this is kind of goofy because we're reading left to right, but it says 0 is less than this quadratic equation. If you read it backwards, you'd say, when is this quadratic equation greater than 0? So now what they're wanting is all the x values that are greater than 0. So where is this graph, where is this function greater than 0? When is it above the x-axis? So it's all of these points here. So how I'm going to answer that again as an interval, this is going to be a union now. We're going to say from -infinity, and now hopefully you can understand the importance of knowing the critical points at 2 and 5, the x-intercepts. So from -infinity to the value of 2, and then unioned with 5 to infinity. So it's two separate regions that satisfy. Now if you're ever not sure about your answer, just take a value in one of these intervals, like find a number between -infinity and 2. Like an easy one is 0, right? Put 0 in for all the x's and see if it's a true inequality. You could also test a point between 5 and infinity, like pick the value of 10. Put 10 in for x and see if the inequality is true. If it is, then you have the correct solution. If it isn't, then go back and look for your mistake. This is actually part 1 of lesson 2.7. I'm going to make a second video, so please look for part 2 of lesson 2.7 coming up soon.